This is an introduction of 4 buck DC-DC converters which are able to provide 100 and 300 mA and have unique features such as an integrated battery voltage monitor and an ultra-low output voltage range. The DC-DC converters have a current consumption of only 0.3 microamp at no load, which is suitable to extend the lifetime of battery-powered devices. Specific applications are mainly in a sleep mode and only wake up briefly to perform a measurement, transmitting some data, and then go back to the sleep mode again. So actually the sleep mode is the main operating mode, and it is necessary to reduce the current consumption in this mode as much as possible. The DC-DC converters fits perfectly in such a requirement with its current consumption of only 0.3 microamp. It is either possible for the engineer to extend battery life or to downsize the battery capacity to reduce the size of the application. The additional battery monitor circuit is one of the key features of the RP514 and 515. A conventional way to measure the remaining battery charge is using an external resistor divider connected to an analog to digital converter. However, the input impedance of this solution is typically low, and the resistor values of the divider should be low as well, resulting in a considerable current flow to ground, draining the battery and limiting the lifetime of the application. The RP514 and 515 provide a simple solution with a built-in resistor divider with high resistor values and a voltage follower as a buffer. An advantage of this circuit is that it has a much lower current flow to ground, and the buffer output is compatible with the input impedance of the analog to digital converter. Additionally, all essential components for this circuit are integrated into the chip, reducing valuable circuit board space and cost. In this way, it is possible to measure the remaining charge left in the battery and make a simple fuel gauge circuit. This slide shows an example of how to use the battery monitor. One can compose a simple 3-stage fuel gauge to measure the remaining charge left in the battery. The battery voltage is used to specify the 3 stages of the battery status, and software advises to replace or charge the battery as soon the voltage reaches its lowest level. The RP514 and 515 both operate in a VFM mode, which is best to achieve a high efficiency performance at low output current demands. The resulting peak efficiency is in the range of 95%. Even at 10 microamp output current, an efficiency performance of about 90% is achieved. This is the actual circuit diagram of the RP514 and 515. It is a simple circuit and requires only a few external components. Note that the product has 2 chip-enabled pins, one to disable the DC-DC converter and the other one to control the battery monitor. By disabling the battery monitor, it is possible to save another 0.1 microamp. The RP514 and 515 have an input voltage range from 1.8 to 5.5 volt. This is the recommended operating voltage range. The output voltage is internally fixed and can be set from 1 to 4 volt in a 100 mV or 50 mV step rate. It has an output voltage accuracy of 1.5%. Maximum output current is 100 mA for the RP514 and 300 mA for the RP515. As for the battery monitor, one can select from 2 product versions with a divider ratio of 1/3 or 1/4 of the input voltage. Also, one can select a version with or without auto-discharge function to discharge the output capacitors when the DC-DC converter is disabled. The RP516 and 517 are similar products like the RP514 and 515, but they lack the battery voltage monitor. Instead, they have an extraordinary low output voltage range, which can be set from 0.3 to 1.2 volt. This kind of power supply is tailored to support the newest generation of low power MCUs, GPS GNSS receiver processors and other ICs for IoT applications in a low power wireless sensor network and wearable devices. The RP516 and 517 both operate in a VFM mode, which is best to achieve a high efficiency performance at low output current demands. The resulting peak efficiency is in the range of 73 to 75%. Even at 10 microamp output current, an efficiency performance of about 67% is achieved. The RP516 and 517 have an input voltage range from 1.8 to 5.5 volt. This is the recommended operating voltage range. The output voltage is internally fixed and can be set from 0.3 to 1.2 volt in a 100 mV or 50 mV step rate. It has an output voltage accuracy level of 1.5 volt. Maximum output current is 100 mA for the RP516 and 300 mA for the RP517. Also, one can select a version with or without auto-discharge function to discharge the output capacitors when the DC-DC converter is disabled. Thank you for watching this presentation. We hope it was of interest for you and helps you to select the right components for your next design. Goodbye and have a nice day.